So here we're using the first principles differentiation method, to find the derivative of fx. Now this is one of the foundational concepts of calculus, but when you're first learning calculus in years 10 or 11, the first principle is differentiation method, formula of which is here. It's one of the first things you run about calculus and differentiation. So it's a very important concept, and we're going to sort of explain it and go through using this example here. So we'll grab the function fx is equal to 5x squared, which I've written down here. Now we need to use this formula here to find the derivative of x. And the derivative is essentially just the gradient, right? We're finding the gradient of a curve, basically, or an equation that's not a straight line. So the two things we need to figure out are fx, which is already given to us, and then f of x plus h, which I have calculated here already. So if f of x is 5x squared, then f of x plus h, that's just 5 bracket x plus h squared. And then we've expanded that and got this answer here. Okay? So you can just pause if you didn't have a look at that, just make sure that makes sense to you. And then we'll continue. So now what we'll do is we'll put it into this first principles differentiation formula. So we've got f dash of x. So this f dash of x just stands for the derivative of fx, or the gradient of fx, is equal to f of x plus h. So as the limit of h goes to 0, it's equal to the f of x plus h, which is this, which is 5x squared plus 10hx plus 5h squared minus f of x, which is just 5x squared. And then that's all divided by h. Now, we've got the 5x squared and negative 5x squared, which just cancels out. And over here, what we can do is we can just simplify out h, so you can get rid of the denominator as well. So as the limit of h goes to 0, which I'll explain what that means later on as well, we've got h 10x plus 5h over h. And then we can cancel these out. So then we're just left with limit h goes to 0, and then 10x plus 5h. So that's essentially what our derivative of f dash x is, or sorry, the derivative of fx is. And this limit of h goes to 0, that just means that our actual derivative is going to be, as h gets closer and closer to 0, what is the value of our derivative get? So if we sub in h is equal to 0 here, our value is just going to get 10x plus 5 times 0, which is just equal to 10x. So basically, the derivative of our function fx is equal to 10x. And depending on what value of x we're at, so if I just draw up a graph, let's get a graph in. Right? And the graph of 5x squared looks something like this. Okay, obviously not drawing the scale here, but it looks something like that. So basically, depending on which value of x we're at, this gradient is going to have different values, right? So for example, at x equal to 1, so if x equal to 1, if you draw a line through there, the gradient at this point is 10. Whereas say when x equal to 5 over here, the gradient at this point, as the tangent touches the curve, is going to be 10 times 5, which is 50. But this basically gives us a formula or a way of figuring out what our gradient is going to be at each of the points of our function.